Today we are going to describe angle pair relationships. We will use special angle relationships to find angle measures. Our warm-up says the sum of two numbers is 90 degrees and one number is 4 times the other. Write an equation and solve to find both numbers. So we have two numbers, we don't know either of them. So to represent the first number, what should we use? X. So there's my first one. One number is 4 times the other, so my other number is represented by 4. We are taking their sum, which means we should and set it equal to. Beautiful. There's our equation. Now we have to solve it. What do we need to do? Combine like terms. And then divide. What do we get for x? Are we done? No, x is only one of our angles. So we know one of them is 18 degrees. The other one is 72 degrees. You could either subtract it from 90 or plug it in and multiply by 4. Complementary angles. Two angles whose sum is 90 degrees. We have a couple pictures drawn to illustrate it. One of them, they are connected to each other, and we use the right angle box. The other two are not connected to each other. They're two separate angles. And if you wanted, you could fill in measures for them. Like you could call one of them 70 degrees and one of them 20 degrees. Just so long as they add up to 90. Supplementary angles, as you might be able to see, are two angles whose sum is 180 degrees. So again, we've got a picture of two separate angles. They both happen to be right angles. They don't have to be, but they can be. 90 plus 90 is 180. The other one, it's a little tricky to see, so I'll re-sketch it above here a little smaller. These ones are connected to each other. And you'll notice they form a straight line when they're put together, and we know a straight line measures 180 degrees. So again, you could fill these in with degree measures like 30 and 150, something that would add up to 180. Adjacent angles, two angles that share a common vertex and side, but have no common interior points. Meaning they are just right next to each other. They don't overlap each other. So we technically have seen a couple pictures of that on the previous slide. But these would be considered adjacent angles. This angle here and this one here. I'm using two different amounts of tick marks or arc marks because those angles are not necessarily congruent. But those are the adjacent angles. They share a vertex and a side, but they don't overlap. For a linear pair, we have two adjacent angles. They are a linear pair if their non-common sides are opposite rays. Note, angles in a linear pair are supplementary. They make up a straight line. They add up to 180. So again, in our examples for supplementary angles, technically we did see one that was a linear pair. I'm going to put it right above the definition. So we've got adjacent angles. So they're right next to each other. They share that vertex. They share that side in the middle. But the non-common sides, the other two sides, are opposite rays. So a linear pair splits a straight line into two angles. Two angles are vertical if their sides form two pairs of opposite rays. An easy way to think about it is just they form an X. Okay, so if here's their intersection point, so we have opposite rays in yellow, that's one pair of opposite rays. I'll do my other opposite rays in blue. Okay, so we can see we have two pairs of opposite rays formed. Notice that those lines are perfectly straight. They don't bend at all. All right, we've got this weird looking figure. We are asked for a pair of complementary angles. So complementary angles add up to 90 degrees. So which two of these angles add up to 90? So be careful about how you name at least one of them. Micah, do you think you know?
I know, but I don't know.
Okay, so what are their measures? Okay, the angles that measure 52 and 38, those ones are complementary, but we do need to be able to name them. You can name them by one letter if there's only one angle at that vertex. So which one only has one angle at the vertex? B. So you can call this one angle B, and that's fine. If you wanted to call it angle ABD, that's the same angle. But if there's only one there, one letter is allowed. Can we call the other angle angle D? No, there are two different angles there, and I wouldn't know which one you're talking about. So you have to use three letters and make sure that D is in the middle. What other two letters help us form that angle? C and B. Okay, so C, D, B is that angle. Or you could call it angle B, D, C. But the vertex point has to be the middle letter. A pair of supplementary angles. Supplementary angles add up to 180. Which two angles add up to 180? Majay? Which two? Good, 128 and 52 would add up to 180. So we have to be able to name them. So one of them could still just be angle B. Still using angle B. How would we name that angle at 128, Micah? EDB. Is that what you said? Yeah, okay, we'll go with that. Angle EDB. Sometimes it's hard for me to hear what letters we're saying, so I just kind of roll with it. E up at the top, down to D, and then we want to cut back up along this line, so we're headed towards B. If you were to talk about angle EDC, you're talking about those two angles combined, which is not what we wanted in this case. All right, last up we need a pair of adjacent angles. Atea?
Angle ABG and EDB.
I definitely like EDB.
Okay.
EDB. So let me highlight that one. EDB. Adjacent angles have to share two things. What do they need to share? A side and a vertex. So which angle shares a side and a vertex with EDB? CDB. Angle CDB would be the one that shares the side and the vertex with it. Right? So even though sometimes we like to think of adjacent as being synonymous with next to, in geometry we get more specific. They have to share a side and a vertex. They have to be right next to each other, not just near each other. Can get a little tricky. Other questions before we move on? Then let's move on. All right, given that angle 1 is a complement of angle 2, and the measure of angle 2 is 57 degrees, find the measure of angle 1. Complementary angles add up to 90. So what do we have to do to find angle 1? Subtract 57 from 90. Good. You do not have to write out 90 minus 57. If you do, that's fine. If there were to be algebraic equations in here, I would expect more work. But if it is as simple as one number minus another number, I don't get super picky about that. What's our answer? 33 degrees for the measure of angle 1. Ready to move on? Some of these go pretty quick. Like this one. Given that angle 3 is a supplement of angle 4, and the measure of angle 4 is 41 degrees, find the measure of angle 3. So something I want to point out that we haven't necessarily talked a whole lot about yet is using numbers to name angles. If you see a little number inside of an angle without a degree measure, that's how they're naming it. So instead of using all the letters and all the points, sometimes they'll just put a number without a degree symbol in there to be able to talk about it a little quicker. Okay, so just a heads up in case that was throwing you off. Back to the problem, supplementary angles add up to, so in order to find the measure of angle 3, we have to subtract again. 180 minus 41 gives us 139 degrees for the measure of angle 3. Questions, concerns? Moving on. All right, the basketball pole forms a pair of supplementary angles with the ground. Find the measure of angle BCA and measure of angle DCA. So they told us in the directions that these angles are supplementary, which means they add up to 180. This problem, I would expect to see a little bit more work shown. How are we going to set it up? Or what's my equation? Deidreana? Oop, forgot my x. Equals? Beautiful. I would expect to see the initial equation. I would expect to see some work from you solving that. Ataya? Usually I don't. Let's get there. So first thing I should do is 3 words. Combine like terms. When I combine like terms, what do I get? Good. 7x plus 5 equals 180. Then we would need to subtract 5. 7x equals 175. And then we would have to divide by 7. And I'm guessing this does not come out nice? Oh, it does. What does it come out to? 25. Okay, good. Okay. Generally, if the decimals don't come out nice and the directions don't tell you to round, then I would either expect an exact answer, like you could leave it as an improper fraction, something along those lines. Are we done with this problem? No, because they didn't want x, they wanted the measures of those two angles. So what do I need to do? Plug it back in. Which one do you want to plug into?
Left.
The left. So we have 3 times 25 plus 8. 3 times 25?
75.
Plus 8. So this angle on the left has a measure of 83 degrees. I'm fine with you labeling it clearly in the diagram, or you can use M angle BCA equals. To find the other one, we could plug the 25 in for x in the right expression, or we could subtract. Personally, I think subtracting is usually quicker. So 180 minus 83 gives me 97. So this one is 97 degrees. Those are the two angles we were asked to find. All right, in example 5, name all of the linear pairs shown. This can get a little tricky. We've got a couple of them. Anybody want to give me one? So pairs, meaning that I should have how many angles at a time? 2. So give me 2 angles that form a line, Kobe. 2 and 3 form a line. Good. So you could say angle 2 and angle 3. That's one pair. What's the other one? Kobe again. 1 and 2. So angle 1 and angle 2. No, I don't care if you put 3 and 2 or 2 and 1. It doesn't matter as long as it is clear which ones you're pairing up. Any other linear pairs? Kobe? Which ones? I don't think we know that for sure. They might have a relationship, but 1 and 3 do not form a line together. Also, they're not adjacent, so we would not consider them a linear pair. Ariana? 1 and 5, they don't have opposite rays, so that doesn't work. Kara? 1 and 4 don't share a side. So the end game of this story is those are the only 2 pairs. Okay, so if we look at like 1 and 5, they share a side, but their rays are not opposite. They don't form a line. 1 and 4 are 2 completely separate angles. 5 is kind of getting in the middle of them, so they don't share a side, even though they do have opposite rays. They don't share a side anywhere. So to be a linear pair, they have to share a side, be adjacent, and form a straight line.
So the same thing with 3 and 5.
Same thing with 3 and 5. They don't actually share a side. Other questions, concerns? Okay, what about vertical angles? I believe there's only one pair of those here. Majay? 3 and 1. Those are the only ones that are vertical. Angle 3 and angle 1. So to be vertical, we have to have 2 pairs of opposite rays. Okay, so we see that the top and bottom are opposite rays. And then going side to side, we have opposite rays. And those form our angles 1 and 3. Questions, concerns? Okay, ready to move on? Number 6, two angles form a linear pair. That gives us a lot of information right away. The measure of one angle is 4 times the measure of the other. Find the measure of each angle. If our angles form a linear pair, what does that mean about their measures?
They're the same.
They don't have to be the same. They could be. Kara?
They make like 180.
They add up to 180. A linear pair forms supplementary angles which add up to 180. Okay, so I always think about linear pair being a line, and most of us already know if we have a straight line, that a straight angle, 180 degrees. Okay, a linear pair forms supplementary angles add up to 180. So much like in one of our warm-ups, we don't know either of those angles. So one of them we would call X, the other one we would call. Okay, and if it's a linear pair, their sum is 180. Okay, much like our warm-up, we combine like terms and solve. What do we get for X this time? 36. But that's not the end of the story. Find the measure of each angle. So one of them is 36. What's the other one? 144. You could either just subtract or take 36 times 4.